Yeah, so we were doing this equation, the third order equation by the variation of parameters method. Okay, so for this characteristic equation, then of course the solution is, let me write the solution first. For the homogeneous part, so YH will be then equal to C1 e power 0 x, okay, because it is 0 over here, and then these are the complex, so their parts, so therefore C1, I can choose C1 cosine of x plus C3 sine of x. Okay, so since this is e power 0x, so it means that y1 solution will be e power 0x, that is just 1, and then y2 will be cosine of x, y3 will be sine of x. Okay, so our next step is now is to calculate the Wronskian. Okay, Wronskian will be then 1 cosine of x sine of x, so 1 0 0, because one derivative of that will be 0 and then 0, then 0, it will be then cosine minus sine x minus cosine x, second derivative sine x, first derivative is cosine of x, and then cosine of x minus sine of x. So what will be the determinant of that? This is a 3 by 3 determinant, so we can it's very easy, because in this case fortunately the one of the in this column you have two values are 0 and 1, then it become very easy to calculate it. So what we do is, in this case, we take this row and then we take this row, and then this is the area, this is the sub determinant which we need to focus on. So that is 1, and then we take the subdeterminant of this, so it is minus sine, that means plus sine square x, and then minus, and then minus into cosine into cosine, so minus minus, then it will be plus, it will be cosine square x. So now you can easily say that it is equal to 1. Okay, I don't need to explain that cosine square x plus cosine square x is equal to 1, so you already know. So Wronskian is simply 1. So actually this has made our task much easier. Okay, so now let's calculate W1. Okay, W1, let me move on to the next page. So for W1 I must have the value of the R of x. R of x is this cosine of x. No, I think in what I want is tangent of x. We'll make a correction. Tangent of x. I want tangent of x. Tangent of x. Okay. So this is R of x. Okay. So W1 is a 3 by 3 also. It will be then 0 0 R of x, which is tangent of x. And now these are this is y2, which was cosine of x, sine of x. Okay, y2 y3, and then minus sine of x, same as before, minus cosine of x, sine of x, cosine of x, and then minus sine of x. So this determinant is also relatively easy, because you see that in this case, in this first column, these are two 0 terms, and then we can just focus on this part. Okay. So for this yeah, these are the rows and columns we will remove, and then remaining area is this. Okay, sine x, cosine x, sine x, sine x. So but we have to be sure about the sign, which will be multiplied. So it is plus minus plus minus plus minus plus. Okay, so it will be tangent of x times cosine of x into cosine of x, cosine square x, and minus sine square x minus minus plus. Okay, so we can see that it is tangent of x very easily. Okay, we just use the shortcut method to calculate the determinant. So it is tangent of x. How about W2? So W2 is then 1 0 0, so it is even simpler actually. So it will be then 0 0. So there are so many zeros, so the determination of this determinant becomes even easier. So 0 0 tangent x. Okay, and then it will be sine x, cosine x, and then minus sine x. So how will we find it? Well, because we can focus from here. Okay, so then for this, then the area of focus is here. So 1, and 0 into minus sine x is 0, and then minus tangent x cosine x. So minus tangent x, and then times cosine x. Okay, so this simplifies into, because we know that tangent is sine over cosine, so cosine cancels this cosine, so it is minus sine x. W2 will be then minus sine x. Yeah, so we don't have to calculate the others, because for this column all the other values are 0, so other two values will be definitely 0. W3, so it is 1 0 0, so y2 was cosine x, then minus sine x, and then minus cosine x, and then it is 0 0 tangent of x. Okay, so now Rx will move here. So for this, what we can do is we can just simply take this first row and first column, and then the area of focus is sine x 0 x, sine x 0, cosine x, and tangent x. So it will be 1 times minus sine x into tangent x, so minus sine x into tangent x, and then minus cosine into 0, so that is 0. So the only thing is remaining here. So this is minus sine x tangent x. Okay, so minus sine x tangent x. So we have found the W. So now we find first one. Now we will have to find the U1 prime. U1 prime is W1 over W. So basically W was 1, so it was actually W1. So W1 was tangent of x. Tangent of x. So if U1 is tangent of x, so then U1 will be then integral of tangent of x, and then we know that the integrand of tangent of x is equal to log of, because it is sine over cosine, so it is log of cosine x, right? It is log of cosine x, or maybe it's minus, because sine over cosine, so cosine derivative is in there, so it will be minus cosine of x. Okay. Minus log of cosine of x. Yeah, now calculate u2. u2 prime is then w2 over w. W was 1, w2 was minus sine of x. So u2 will be then minus sine of x dx. So what it will be? So it will be cosine of x. Yeah, cosine, and then derivative, so minus sine. So minus sine, yes, it should be cosine of x. So it is cosine of x. Okay, so u3 prime is equal to w3 over w, and simply it is minus sine x tangent of x. Yes, minus sine x tangent of x. So this we can simplify. So u3 will be then equal to minus sine x into tangent of x. Okay, so this integral need to take some time. So maybe how we can find, so maybe it is, you can take it like sine x into sine x over cosine x. Sine x, so it's sine square x over cosine x dx. It is sine square x over cosine x dx, or it can also be written as minus here 1 minus cosine square x over cosine x dx. So it can be written also as like this, cosine square x minus 1 over cosine of x dx, because I bring inside this minus 1, and then it can be written as cosine x minus secant x. Okay, so now I think it's relatively easy, because we know that the integral of cosine x is sine x, and the integral of minus secant x is log of secant x plus tangent x. Okay, well, this is a little bit, we need some steps to prove it, but I think it's fine. Maybe from your calculus class you already have done it many times, and then since secant x is just a primary function, so it's okay to directly write down the integral for this function, and this is also available in the tables as well. So finally we have found u1, u2, u3. So therefore our yp will be equal to y1. y1 was 1, so yp will be equal to y1 u1 plus y2 u2 plus y3 u3. Okay, so now we can write y1 was 1, u1 was u1 was log of sin x. Okay, log of sin x, and then y2 was cosine x, and u2 was sin x. u2 was also cosine x. Okay, u2 was cosine x, so it's times cosine x, and y3 was sin x, and then u3 is sin x minus log of secant x plus tangent x. Okay, so here what we have now this, so log of cosine x plus cosine square x, okay, multiply it plus sine square x minus sine x into log of secant x plus tangent x. Okay, and therefore now we can write the complete solution. The complete solution was homogeneous. Homogeneous was where? Homogeneous is here. Yeah, c1 plus c2 cosine x plus c3 sin x. So it was c3. It was c1 e power 0x. So it's simply c1 plus c2 cosine x plus c3 sin x, and now log of cosine x plus, this is now 1. Okay, this is now 1. Cosine square x plus sine square x is 1, and yeah, okay, so this is the solution, and then there is one correction that it should be minus over here, minus, and because in over here it was minus, and then we combine these constants into this constant C4.